Here we go. All right. So this is section 3.6. Now you're probably wondering, didn't we just have a chapter 3 test? Why are we doing section 3.6 when we just had a chapter 3 test? Well, that's because the first 5 sections of chapter 3 are all about graphing, right? You probably noticed that when you got to the test, you were like, oh, there's a whole lot of graphing on this test. But the first 3 sections, the first 5 sections of chapter 3 are all about graphing. And then there's this one section right at the end that's about graphs, but it's not much about graphing. It's something called functions. And functions, I would say, are one of the most important things to know how to understand in math. Right? I would put it in the same level as, I almost would put it on the same level as chapter 2 when we talked about doing basic algebra stuff, right? Moving around numbers and letters and stuff, right? All the stuff we did when we had 2x plus 5 equals 7. As important as that. As important as, okay, how do I get x over here, and what's legal for me to do and what's illegal for me to do, and then how do I do this and how I do that? Like, it's on the same level as that, basically. So functions are really important. Graphing, you can mostly do it on your calculator. You just punch into a thing and you do it in your calculator. I mean, really, you honestly can do it in your calculator. Without really understanding what you're doing at all. Functions, though, you kind of do have to understand them. So I'm going to go through this section. And there are a good many slides in this presentation. So I'm going to go through it, but then you probably need to go through it again and look at them and make sure you understand everything I said. All right. To begin with, let me talk about something that isn't a function. Let's talk about a relation. Now, what is a relation? Relation basically is the relationship between 2 variables, and we use ordered pairs to talk about them. So, for example, let's say we were talking about hours and wages. So something simple. I work a minimum wage job, maybe. So let's say I worked a minimum wage job, which I've done before. It's a job. Nothing wrong with it, nothing good, bad about it, just it's a job. You work a minimum wage job and you get paid about $8 an hour. I mean, nothing fancy, nothing, yeah. Now let's think about, if I was thinking about that job and number of hours, because this is kind of the math I would be doing in my head all the time, right? Because I'm, this is my money. I'm going to be thinking about this math constantly. This is not abstract math. This is real math, real life math here. And I wake up in the morning and think to myself, okay, if I don't go to work at all, if I just skip work, how much money do I make? Well, I know that. That's really easy. I make $0. All right. And if I work for an hour, I think, well, how much money would I make if I work for an hour? And then dip out. I make about $8, which is not a lot. If I work 2 hours, I make $16. If I work 3 hours, I make $24. Now, I make approximately that. Obviously, you have to think about FICA, Medicare, and Social Security, and all that kind of stuff. You know the drill. I mean, they're taking all kinds of money out of your check. But that's basically how much money I would make if I was working X number of hours. Okay? So how would I write that in a fancy math way? Well, one thing I could do was I could use that thing I used before called a table. And I could just simply take the hours and the wages and just list them. Okay, if I work 0 hours, I get $0. If I work 1 hour, I get $8. Work 2 hours, I get $16. 3 hours, I get $24. So I could write it that way. I could take all the information, put it into a table, right? You've seen a table before, you know what a table looks like. And I could basically just list them out, hours, wages, like so. That's one way I could write it. Another way I could write it is I could write it like this. I could say, well, those are ordered pairs, right? We did that in chapter 3. We basically took a table, we made ordered pairs. All right. Go back to chapter 3. You have the PowerPoint for that. So if you go back to chapter 3, you'll see that there's there's this thing we did. All right. So 0, 0, 1, 8, 2, 16, and 324. That's okay. All right. So we can write ordered pairs. Now that is what we actually call a relation. This right here is officially what we call a relation. I'm not going to dwell too much on that. That's just kind of, there's some official terminology we use for things, but a relation is basically a relationship between two variables. All right. And obviously, remember, we could just graph this stuff too, right? I mean, I could take that table and I could graph it. I mean, yeah, why not? I mean, and as you can see, the more hours that you work, the more money you'll make. You can kind of just, if you can just see that visually, right? You can just see that, like, as one thing increases, the other thing increases. And so, we can see basically that you probably do want to work more hours to get more money, but you already knew that. This is just mathematically, this is kind of how we show it, right? This is how we prove it, quote unquote, right? Well, this is how we go. Someone goes, well, I don't believe you. I don't know if working more hours will get me more money. Well, I have proof. I have that. Look at that. That's proof, whatever. Now, there's actually one more way that we can write this out, and what we call is a mapping diagram. So that's called a mapping diagram. I'll talk about that in a second. But just to recap, basically, that's what we know. We know that already. I mean, you guys work jobs. You know basically how making $8 an hour works. You've lived it, essentially. We could write it as a table. You could write it as ordered pairs. You could write it as a graph, which we've done before. We've done all 3 of those things, right? And you could write it as a mapping diagram. Those are 4 different ways of basically writing data out. Now, let's talk about this mapping diagram thing. If we look at this table here, it tells us that we have 0, 1, 2 for X and -1, 1, 3 for Y. So if we just think about it logically here, 0 goes with -1, 1 goes with 1, and 2 goes with 3. So if I was to take that, if I was to think about that logically, I would say, okay, well, what goes with what? 0 goes with -1, 1 goes with 1, 2 goes with 3. That's what it's saying. If you go back here, let's go back to this example here. If I work 0 hours, I get $0. If I work 1 hour, I get $8. work 2 hours, I get $16. If I work 3 hours, I get $24. And that actually makes sense. So if I was to match them up, I could draw a line, an arrow through them, kind of like what you did before, like a matching game you might have did as a kid or something. Just draw a line to do the thing. All right. So we can do the same thing. Let's look at this graph here. Let's table here. I got 1, 5, 1, 7, 2, 7, and 3, 9. So 1, 5, 1 goes with 5, but 1 also goes with 7. Okay, so that line goes from 1 to 5 and 1 to 7. 2 goes with 7, and 3 goes with 9. All right. Now, it seems like I'm sort of belaboring this point. And it's a really obvious point. But the reason I'm doing this is because I really want you to understand how a function works. Okay? What you're doing is you're just trying to figure out what x goes with what y. That's it. If I do x, then I get y. Or if I do x, then I get y. Basically, that's what you're trying to figure out. If I plug in an x, what y do I get? That's it. That's all you're trying to figure out. And you're gonna want to overcomplicate it because once we start giving it notation, you're gonna want to multiply and divide and subtract and add and take square roots and all kinds of stuff. You're gonna want to complicate it. I really don't want you to complicate it. 1 goes with 5, 1 goes with 7, 2 goes with 7, 3 goes with 9. See what numbers go together. That's it. What x's go with which y's. That's it. All right. Now, when we think about a relation, all right, we can talk about two different things. Domain, which are essentially your inputs, and the range. The domain of a relation are all the x values, and the range are all the y values. Okay? So, if I look at this relation right here, I've got 0, 1, 2, and 3. Now, 0, 1, 2, 3, these are x values. As you can see, so 0, 1, 2, 3 are my x values, right? Because every ordered pair has an x and a y. This is an x, that's 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 a y. In fact, if you wanted to, you honestly could. And it's not a terrible idea. Just honestly go through and see. Mouse. Of course, I put it there. You can say, oh, x, y, x, y, x, y. Well, that's obvious. It's not. Anyway, one thing I think the students don't do enough of, because they just don't feel like it, or they just don't want to, or they just forget to do it, or they're absent-minded, or whatever, is labeling stuff. They don't like labeling stuff. They go, I don't want to label stuff. Why not? It makes your job a whole lot easier. I mean, just label it. I mean, if you label everything, you know what the X's are now. So now the domain is really obvious, right? The domain, there's the X values, right? Well, what are the X values? Well, I don't have to be a rocket scientist to figure out what the X values are because I labeled them. I mean, it's not. Again, we want to make sure it's not rocket science. We're not working at NASA. We're not here to do rocket science. We're here to make things as simple as possible. Now, range are the Y values. Okay, what are the Y values? Well, I labeled them. So I know what they are. Because even though I'm not a rocket scientist and I'm not, especially great at mathematics necessarily, I can look at that and go, I know the Y values are because I wrote down what they are. Again, I'm not a rocket scientist. I know a guy who's a rocket scientist, and I'm not as smart as he is. So I'm not here to be a rocket scientist. I'm here to keep things as simple as possible so that I can get it done. So the domain are the X values. So if I take this set of ordered pairs and I just label them X, Y, X, Y, X, Y, X, Y, which is good practice anyway, then basically I go, that's an X, and that's an X, and that's an X, and that's an X. Now, if you don't like that, you can always just go, that's a good way of doing it. Maybe it doesn't make sense to you. Maybe just go, and you go, oh, those are my X values, those are my Y values. I mean, you can even color code it. You can be like, and now you can see they're different because you go red and blue. Red, blue. So there's just a bunch of things you can do. I mean, there's a whole bunch of ways to approach it. You can always, there's so many different ways of doing this stuff, of differentiating different things. So that's one thing I like. I don't really color code because for me, color coding doesn't work as much. But some people love color coding. Some people love to circle and do triangles and squares. Some people like they label them X, Y. Some people underline and double underline. There's a whole bunch of ways of doing it. But whatever can help you to differentiate the two of them, essentially. See which things are different. So again, that's just something that I like to do. So hopefully you can see that. It's very simple. It's just you gotta just kind of keep things differentiated. All right, cool. So that means we can ask some questions like, what's the domain and range of the relation 1, 6, 9, 8, -8, -5, 1, -5? All right. So you probably already know the answer to this. I'll just go through it real quick. Basically, I have my X values, which in this case I color coded. and my y value, which I've color coded as blue. Again, you can do xy, 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 xy. Works the same way. It's just a kind of, and that actually is kind of helpful to me, because what will happen is, if I'm looking at like a long list of things, my brain will start to get things backwards. Like I'll go x, y, x, y, x, y, y, x, y, x, y, 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 x, x, y, x, y, y. My brain will get things backwards if I'm looking at a long list of things. So just labeling things actually helps me. All right. So domain, it's 1, 9, and -8. Now, I want you to notice that the one over here. Now, if we were doing a paper test and you put a 1, and you put 1, 9, -8, 1, I wouldn't count off, because I get what you're saying. The computer, and this is really important, the computer doesn't like it when you do that, because technically you're not supposed to. So if there's a 1 at the beginning and another 1, it doesn't like it when you write that in the domain. So it's going to yell at you a few times, because you're going to want to put that other 1 there, and it's going to keep yelling at you. And I want you to know why. The reason why it's going to keep yelling at you is because it doesn't like it when you write that 1 again. The range, let's look at the range. I have 6, 8, -5, -5. Now the answer it wants is 6, 8, -5. If you write 6, 8, -5, comma, -5, it's going to yell at you a little bit, and you're not going to know why. That's why, because it doesn't like it when you write the number twice, when you don't have to. We already know the number 5 in the range. We don't have to write it again. So it's like, why are you writing this again? Stop doing that, right? We already know there's a 1 in the domain. It's right here. Why are you writing it again? Stop writing it again, because it gets annoyed that you wrote the same number twice for the domain. So that's just something, it's kind of one of those quirks of the system that you're going to run into. Don't panic. Just that's why it doesn't like it, because it doesn't like it when you write the same number twice for the domain or for the range. But you'll figure that out if you just look closely at the correct answer. All right. So I'm not going to go through that too much. Let's go to the second bit, which is functions. Let me kind of go back to sort of the beginning, do a little bit of a recap. All right, at the beginning we defined a relation. We said that a relation basically is information that we know, and we are using that information to, and we're gonna represent it mathematically, essentially. Stuff you already know. If you work an 8 hour, if you work an $8 an hour job, sorry. If you work an $8 an hour job and you don't work at all, you get $0. If you work 1 hour, you get $8. Work 2 hours, you get $16. Work 3 hours, you get $24. And we wrote that as a table. We wrote that as ordered pairs. We wrote that as a graph. And we wrote that as a mapping diagram, which we just defined, a mapping diagram. Basically, what goes with what? Well, 0 goes with 0, 1 goes with 8, 2 goes with 16, 3 goes with 24, right? Yes. All right. Then we talked about the same idea. What goes with what? That's basically all we're doing. All right. Let me see what I got here. Domain and range we did. All right. Now we're back on the functions. Okay. So we define a relation as a set of ordered pairs. All right. That's a relation. And when it says tell if the relation is a function, it's talking about tell me if that is a function, basically. All right. That's basically what we're asking. Is that a function? Now, some relations are functions, and some of them are not functions. So some are and some aren't. Some are and some aren't. Okay? How do we figure out if they are functions or if they aren't functions? Well, we have two pretty easy tests to tell us that. All right? And it depends on whether we have a graph or not, essentially. The first test is what we call repeating x's. Do we have x's that are repeating? And x shows up more than once. And the second thing is called the vertical line test, or we call the pencil test in mathematics. Just because that's easier to remember for lots of people. But it's called vertical line test. So here's the question. Is it a function or is it not a function? So let's look at the first example. And let's ask the question, is the relation 1, 4, 1, 5, 2, 3, 3, 4, does that represent a function, is the question. And the main question we're going to be asking is, do we have any x's that show up more than once? So let's just look at it. I mean, I'm not going to belabor the point. You can look at it. You can see. That's an x. That's an x. That's an x. And that's an x. 1, 1, 2, 3. Well, what's the answer? Well, yeah. 1 shows up more than once. Now, if you wanted to, you could label it. You could say x, y, x, y, x, y, x, y. And you would see pretty obviously. I'm not gonna go over that too much. I mean, you can look at it, you can tell. You're smart people. All right, you can see that 1 shows up more than once. Well, that's a problem for us. We don't like that. If x shows up more than once, repeating x's, then it is not a function. So it's very important. If x shows up more than once, it is not a function. All right? So I have this x is 1. It shows up more than once. It's not a function. Okay. Example number 2. Let's look at this one. I got 1, 7, 2, 7, 3, 8. All right, let's look and see. Do any of the x's repeat? I got a 1, a 2, and a 3. Those are my x values, my domain, right? All right, do any of the x's show up more than once? Well, it's 1, 2, and 3. Those are all different numbers. No, none of the x's show up more than once. All right, does it mean it's a function? Yes, it's a function. We don't have that problem that we don't like. So it is a function. That's it. All right. Okay. So here's our basic rule, and I'll say it again. If a relation has repeating x's, if any of the x's show up more than once, we don't like that. It is not a function. So if any x's show up more than once, it's not a function. Okay. Well, now we can look at a mapping diagram. Okay. So let's look at this thing we call a mapping diagram, and let's see whether it represents a function. All right, I've got 2, 4, and 3. Now, just from looking at the diagram, you probably won't be able to tell necessarily if it's a function or not a function, because you'll say, well, 2 shows up once, and 4 shows up once, and 3 shows up once. No, not necessarily. Let's think about this, and what we're going to do is we're going to write this in terms of ordered pairs. So if I wrote that in terms of ordered pairs, 2 goes with what? It goes with 20. So 220, that would be something we could say, right? And 2 also goes with 40. So 240. 4 goes with 40, and 3 goes with 30. If I wrote that as ordered pairs, it would look something like that. Now can I check to see if it's a function? Yes. Is it easy? Yes, it is. Well, what's my criteria? Well, if any of the x's get repeated, if any x shows up more than once, it's not a function. So let's check and see if that's so. I got a 2 here and a 2 there. It's not a function. It isn't. In the same way, I could look at this example, write these as ordered pairs to kind of make it easier for myself. So I'll write them as ordered pairs. I get this whole situation. And that tells me that it is a function because none of the x's repeat. They're all different. Cool. All right, so that's how we use the repeated x test. So we just went through the first one, the repeating x test. And all of this is on PowerPoint, so I just want you to kind of understand it. You can go back and look at it, and you can copy all this stuff on a notebook or whatever, notepad or whatever later. I just want you to kind of understand it. That basically all we're looking for is, do any of the x's repeat? If any x's repeat, it's not a function. We don't like that. All right, the second test that we use, besides the vertical line test, or besides the repeating x test, is what we call the vertical line test. The vertical line test says if it fails the VLT, I'm gonna call it the VLT sometimes, just because I'll get tired of saying vertical line test. I might even say pencil test if I feel inclined to do so. But think of them as the same thing. If it fails, the vertical line test is not a function. All right, how do you fail the vertical line test is the question, right? Here's the answer. If you take a pencil and you line it up and down on the graph, and it passes through the line more than once, it fails the vertical line test. So let's think about, okay, let's see that. So basically, you can see illustrated here, I have a ruler that I took, and I basically lined it up like that. And when I lined it up, it failed the test. All right. Someone's making alteration to my thing. I don't like that. Okay. I'm not gonna worry about it. I don't know how to fix it. All right. So let's check and see if it's a function or not a function. So we're gonna look at it basically. If it's a function, all right, let me stop my share real quick. All right. They're on track. Great. So let's look at this function thing, and let's see if it's a function or not a function. Look, I know I'm going to this real slow and real laboriously, and you're like, oh my gosh. But I'm trying to make sure everyone gets everything. Okay. All right. Basically, if I draw a line through here, at no point will I ever be able to cross it more than once. Let me go. No, that's once. That's once. That's once. That's once. 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 All right. If I draw a line right there, oh, that goes through that twice. That goes through it twice. It hits here and it hits there. This goes through it twice, hits here and hits there. That's it. All right, that's a function. It passes the vertical line test, the pencil test. This is not a function, it fails it. You don't want to overthink it, honestly. Just try to draw a line through it. Like, and just take a pencil or something, just try to draw a little line through it, going up and down and seeing, does it go through more than once? If so, it's not a function. Take a pencil. You can always just take a pencil, right? This is a pen, but yeah. You always take a pen, you just gotta hold up to it like this. And go, does it go through more than once? Yes. Okay, not a function. Cool. Not rocket science. So like this graph here, if I were to take this graph and just like that, it goes through more than once. It fails the test. All right. Let me see if I can. Yeah. It fails. I can do that. It fails. It fails. That's it. Don't overthink it. All right, am I still in a pen? No. Got it? Great. Cool. I can do the same thing here. It passes. It passes. It passes. It passes. It passes. Still passes. Still passes. It passes. It passes. Yeah. Cool. Again, not rocket science. Don't make it rocket science. We're not working for NASA. Don't make this a NASA space program. This is literally just draw a couple of lines, put up a pencil or something, figure it out. All right, we're gonna get to the last bit of it, and we got a little bit of time. All right, I'm not gonna belabor the point on this either. Again, this is very simple stuff. I'm going over it just because you may have not seen this before, or you may be rusty on it. So this is all kind of recapping stuff we've seen before, that you should have seen before at least. All right, plugging stuff in. So when I say the word evaluating functions, it sounds like something a little more complicated than it is. It's not complicated. Basically, all you're doing is plugging stuff in. That's what when I say evaluating a function, I mean plugging stuff in. All right. So we did this for a table. We plugged in, we got an X, plugged in a Y. If you knew how to do that, you'll know how to do this. If you don't know how to do the other thing, you're gonna have a hard time with this thing. It's not gonna get any easier until you figure out how to do the other thing. Now, some of you have problems with that. You need to go back to those problems and you need to go back and learn how to do that, filling in a table situation. All right? Because this will not get any easier, because it's essentially exactly the same thing. I'm not going to go back through that. That's something you need to practice basically and get kind of good at. All right. But I want you to notice the notation. it's f of x equals 3x minus 1. F of 0 equals 3 times 0 minus 1. So I'm substituting 0 for x. My calculator will do most of that. 0 minus 1 is -1. It helps to have a calculator, guys. Especially if you don't have a lot of math classes. Like if you plan on doing some more math classes, you should get a calculator. I mean, I don't, yeah. Get a calculator. Get the cheapest calculator you can find that will still do smart. They'll still be smart. Get the cheapest calculator you can find that will still do smart things for you. If you plan on doing something for a long time, you might get one of those really fancy top shelf calculators. But you can find you a little. I found a pretty decent calculator for about $15 on Amazon. So, or I think it was $10 plus shipping, so $15 or so on Amazon. So it was get a calculator if you're gonna be doing some more math. Just go ahead and do it. Great. All right. So your calculator will do most of this. So I'm not going to belabor that point. All right. All right. Let me remind you about a couple of things. PEMDAS, please excuse my dear Aunt Sally, and exponents. And let me just show you a couple examples. I'm not going to really do the first example. I'm going to kind of overlook. I'm going to look at the second example just to make sure we got some stuff down. All right. Again, this is review from kind of plugging stuff in before. But basically, if I want to evaluate g of x equals x squared minus 4x plus 1 for x -1, 1, and 2, I'm going to go in where I see an x. I'm going to put -1. Now, I want you to notice that I put it in parentheses. I put it in parentheses. If you don't put it in parentheses, you're not going to get the right answer. When you put in your calculator is not going to, it's going to do exactly what you tell it to do. All right. So, I don't know if you can see that or not. Probably can't. Let's see. You can't. Doesn't matter. Let me see. I can. Yeah. Doesn't matter. All right. Well, kind of does. But you'll notice that if you put -1 squared in your calculator and you put it as -1 squared without a parentheses, it will tell you it's equal to -1. And you'll write -1 in your paper. And your calculator did exactly what you asked it to do. But that's incorrect. If you put parentheses -1 parentheses squared in your calculator, it will give you +1, which is the correct answer. Again, your calculator will do exactly what you tell it to do. Make sure you're telling it to do the right thing. So when you plug these numbers in, like -1, 1, and 2, even if they're positive numbers, go ahead and put them in parentheses. So parentheses -1 squared minus 4 parentheses -1. So that when you go to your calculator and you do these different parts, it will do these things correctly. In fact, you may even be able to put it all at the same time if you have a nice enough calculator, about a $15 calculator or so, $20 calculator. I mean, a $1 calculator won't do it, but a $15 calculator will do it if you invest that much into it. All right. You should be able to just put it all in one time, and it will actually tell you the answer like that, just lickety split. All right. You gotta make sure you use order of operations, parentheses, exponents, multiplication, division, addition, and subtraction. and so on and so forth. All right, I have some more examples here. You can look at those. Basically, I'm just showing you lots of different examples. All right, cool. I'm gonna summarize. Today, we learned about what are called relations. What are relations? The set of ordered pairs. All right. We learned about mapping diagrams, ordered pairs, tables, graphs. We saw all those things. We saw that you can check to see whether a relation is a function or not a function using two different tests. Two different tests, we said. All right. First test, test number one, we said was repeated x's. Test number two, vertical line test. We went over that. That's in the slides. You can go back and look at it. I'm not going to talk about it anymore. All right. And then we said the relation or function has two different things. It's got a domain. It's got a range. The domain are the x values. The range are the y values. Oh, I did do a slide on it. Okay. So we said, all right, if the x's are repeating, it's not a function. Vertical line test, if it crosses more than once, it's not a function. Then we said plugging stuff, evaluating is the same as plugging stuff in. You plug stuff in, make sure you use order of operations. Please excuse my dear Aunt Sally. All right. And then we did that. I think that's it. There might be one more thing I was going to talk about. No. All right. There is new homework up. Make sure you start on that homework. I will tell you tomorrow or later this week when the final is supposed to be. Assuming they know, they can tell me, and I'll tell you. And then I'll tell you whether we're having a fourth test, or whether we're going to have 3 tests and a final. So I'll let you know later this week. There is homework up. You can go and start on that. It started at 9 o'clock, which is about 9 right now. So you can get started on that as soon as you finish here, if you have the time, if you're not going to work or something. Great. I'm going to stop recording. I'm going to stop sharing first. I'm going to stop recording.